All right, guys, so this is the second half of 9495. So this will be 9495B. And once again, we're going to do a worksheet as our homework, not out of big ideas. So yesterday we talked about, or I guess not yesterday, the day before, we talked about sine, cosine, tangent, all that, and what the values of those were. So now we're going to do kind of the same thing, but different. But this is going to require our calculator, okay? So what I need you to do is I need you to make sure whatever calculator you're using is in degree mode. Okay, so go ahead and do that. Otherwise, you will get some really wonky answers. All right, so after you made sure you're in degree mode, now what we're going to do today is we're going to talk about and discover and practice how sine, cosine, and tangent can help us find side lengths. And I'm going to put side lengths of triangles, okay? So we can use sine, cosine, and tangents to help us find the lengths of unknown sides. So if we look at this triangle here, we notice it's a right triangle, which you have to have a right triangle in order to use sine, cosine, tangent. And we only have one side, okay? We know this side is 11. We would need two sides to tell us, or to allow us to use Pythagorean theorem, so we can't use that. So what I'm gonna go ahead and do is, since I know that this angle here is 32, this is gonna be my reference angle, okay? And so I'm gonna label all three of these sides just like I have before: my hypotenuse, my opposite, and my adjacent. Okay, and let's say, I don't know, let's say I want to solve x first. It doesn't matter. Okay, so x is right down here, and we know x is the adjacent side. Okay, and my opposite side is 11, which is the side that we know. Okay, so I want to look at SOHCAHTOA. Okay, and when I do that, I want to look, see, the side that we know is our opposite, the side that we need is our adjacent, so we have O and we have A. So I want to see which one of these has O and A paired together. That would be tangent. Okay, so I would just write the tangent of this angle, which is 32 degrees, equals opposite, which is 11, over adjacent, which is x. Okay, so this is basically the same thing we did yesterday, except for we're plugging this in and we don't have both of these. Okay, now the really cool thing is if you put tangent of 32 into your calculator, you'll get a big long decimal. Okay, your calculator knows what the tangent of 32 is. Okay, so what I want to do is just simple algebra where I want to get x by itself. Okay, then I want to solve for x. So I'm going to multiply both sides by x. Those will go away. So I'm left with x times tangent 32 degrees equals 11. Okay, now to get x by itself, I'm going to divide by tangent 32. Divide by tangent 32. Remember, this goes away. So I'm just left with x equals 11 over tangent 32 degrees. Now remember, tangent 32 degrees is just a number. So all I'm going to do is I'm going to put this here in my calculator. So 11 divided by tangent 32 in my calculator, and I get roughly 17.6. Okay. Now, next I want to solve for my y. Okay, so notice my y is the hypotenuse. Okay, so I want something that uses the hypotenuse, and this is a decimal and it's rounded, so I'm just going to go back to what we know. We know my opposite. Okay, so we know my opposite. I want my hypotenuse. So I'm going to look down here at sine, cosine, and tangent and ask myself, what pairs O and H together? Okay, sine pairs O and H together. So I know that sine of theta equals opposite over hypotenuse. Okay, well, I have sine, and I know my theta. My theta is 32 degrees. Equals my opposite is 11 over my hypotenuse, which is y. Okay, now we're down to an algebra problem. So once again, I'm going to multiply by the denominator to get rid of the fractions. Those go away. I'm left with y times sine 32 degrees equals 11. I want y by itself, so I'm going to divide by sine 32. Divide by sine 32. And remember, sine 32 is just a number, and our calculator knows what that number is. So y equals 11 over sine 32 degrees. Now I'm going to put this here, 11 over sine 32, into my calculator. And I get roughly, y is roughly 20.76-ish. Okay? And that's how I use sine, cosine, and tangent to solve for side lengths. All right, I want you to go ahead and try example 2 on your own. Go ahead and try A and try B. Remember to label each side O, H, and A before you get going, and then we'll go over these. All right, let's go over these. So on A, we have our opposite, and the first thing I did is I solved for x, so I want my adjacent. So I go back up here to sine and cosine, and I see opposite and adjacent go together with tangent. So I use tangent of my reference angle 61 degrees, and that's going to equal, my tangent's always opposite over adjacent, so opposite is 22, my adjacent is x. Okay, and then I go through and I solve for x, I get x equals 12.2. To solve for my y, I look up here in my h, my hypotenuse is y, and once again I have my opposite, so I'm going to look up here and see where does opposite and hypotenuse go together. Well, right here with sine, so I'm going to use sine. So I say sine of 61 is opposite over hypotenuse, so 22 over y, and then I go through and solve and I get y equals 25.2. All right, on B, to solve for x, x is my opposite, I know my adjacent, so tangent is opposite and adjacent together. So tangent of 56 equals x over 13. You solve for x, you get roughly 19.3. And then for my y, notice I have my y is my hypotenuse, and I have my adjacent, so my cosine pairs adjacent and hypotenuse together. So I have cosine of 56 degrees equals 13 over y. Go through and solve for y, I get roughly 23.2. All right, so this question has several parts to it. So first I want to solve for x and y using trigonometric ratios. So I'm going to use 26 as my reference angle. This is my opposite, my hypotenuse, and my adjacent. Okay, I was right. So, toa at the top of the page. All right, so let's solve for x first. My x is my opposite, and I know my hypotenuse. Okay, so I want to go up here to sine, cosine, and tangent and ask myself, where is h and o paired together? And it's right here with sine. So I can say that the sine of theta equals opposite over hypotenuse. Okay, now I'm just going to plug stuff in. So sine of, I know my angle measures 26, so sine of 26 degrees equals my opposite is my x over my hypotenuse, which is 14. Okay, so I want to get x by itself, so I'm going to multiply both sides by 14. I have 14 times sine of 26 equals x, and I just plug this straight into my calculator. So 14 sine 26, I get roughly, x is roughly 6.1. Okay, so I'm going to write 6.1 over here. All right, let's do the same thing for my y. Okay, now my y is my adjacent side, and this is rounded, so I'm not going to use this. I'm going to go ahead and use my unrounded side, which is my h. Okay, so I want my adjacent, I have my hypotenuse, so I'm going to look up here and see which trig function has h and a together. Okay, well, h and a come together with cosine. So I can say the cosine of theta is always equal to adjacent over hypotenuse. Now let's plug in stuff in. So cosine, I know my theta, I know my angle measure is 26, equals my adjacent is y over my hypotenuse is 14. Okay, now to solve, I'm going to multiply by the denominator. Those go away. I'm left with 14 cosine of 26 degrees equals y. And then I'm just going to plug this into my calculator. And I get that y is roughly 12.6. So I'm going to put right here 12.6. All right, so now that we know that, I'm going to make this A, this B, and this C. I want you to go ahead and find the sine of A, sine of B, cosine of A, cosine of B, tangent of A, and tangent of B. And put these in decimal form, round them to the nearest tenth. So I'm going to let you do that, and then we'll go over them. All right. So when I went and I found my sine of A, sine is opposite over hypotenuse, so 12.6 over 14, which goes to roughly 0.9. Okay, sine of B, you flip, right? You have to, the adjacent and the opposite changes from A to B. So the opposite of side B is 6.1 over the hypotenuse is still 14, which gives you 0.4. Cosine of A is 0.4, cosine of B is 0.9, tangent of A 2.1, tangent of B 48. So I want you to go ahead and look at something. Okay, we know that angle B, which is this, this, and this, is 26 degrees. Okay, so I want you to go ahead and put in your calculator, what is the sine of 26 degrees? You should have gotten roughly 0.44. Okay, what is the cosine of 26 degrees? You should have gotten roughly 0.9. And what is the tangent of 26 degrees? You should have gotten 0.49-ish. Okay, now remember, these are all rounded, and notice how similar these are to this. This is to this, and this is to this, okay? The same is true. If this is a 26-degree angle, this would be a 64-degree angle. And if you did the sine, cosine, and tangent of 64, it'd be very, very close to this, this, and this.